So the first landing mechanism that I will show you then was NASA's Pathfinder mission back in 1977. Successful landing, and here's how they did it. Take a look. So here goes the rocket. They got to get there 25,000 miles an hour somehow. This is not real footage, by the way. This is all a computer animation of the whole mission, but very, very, very well done. It would be impossible to get footage of this. So the parts of the rocket that broke off are empty of fuel. Those are empty of fuel now. You just get rid of them. You don't need to carry empty fuel tanks with you. That's stage 2. Very limited fuel, but gives it a little more push. Not going to the moon, though. It looks like it is. Fairing deployed. That's the spacecraft there. They get it spinning because that gives it a great deal of stability. All these little thrusters, not a lot of fuel on board, but a little more thrust.
We don't fire a rocket motor all the way to Mars. We don't need to. We just place the spacecraft on a trajectory to Mars and let it coast for 7 months and 300 million miles until it reaches the planet.
See that? Coasted for 7 months. So you get your 25,000 miles per hour, and it just coasts. So when that last rocket fired, that was it for the fuel. There's no more fuel. And it gets kind of tense here 7 months later when we're about to land, because we don't know if we're going to make it or not. Isn't that something? Getting close to Mars. There's the atmosphere, the thin atmosphere. Will cause some burning and some effects. Very thin, though, nothing like on Earth.
We've just passed 1 minute atmospheric entry, current altitude 121 miles, current velocity 12,000.
Very stressful in the control room.
We are now at an altitude of 73 miles, moving at a speed of 12,192 miles per hour.
Is that 12,000 miles per hour?
In 5 seconds. 4, 3, 2, 1, mark.
Okay. Limited use of a parachute. Slow us down a little bit. Not enough for the full slowdown, though.
Spacecraft reporting that heat shield has indeed jettisoned. Lander separation event has been detected. Spacecraft reporting lander is separated, moving at a speed of 173 miles per hour. We are near our terminal velocity.
Airbags. A little bit of fuel left. But there you go. There's the rest of the way.
At this point in time, we should be on the ground. Any signal that we receive from now indicates the vehicle would be alive, on the ground and bouncing. The spacecraft has to survive all the bounces for landing to be a success.
Can you imagine if you were a Martian on the planet, having a picnic, watching this thing fall out of the sky?
No signal at the moment. Stand by.
And
Signal strength is currently intermittent.
they just don't know if it made it or not. Remember, all this footage
Signal at the moment.
is not real, but they just don't know if it made it. Pretty exciting, huh? Solar panels come out for power, keeping batteries charged.
The first thing we have to do after we land is open our solar panels to the sun so we'll have some power. This charges up the batteries. After that, we can deploy the camera mast so the rover can see, and deploy the antenna so the rover can talk to us.
The first pictures from Mars. That's looking down on our vehicle.
So can you just imagine how exciting it is? For 7 months, the spacecraft is coasting to Mars, and suddenly it's landing day, and your fingers are crossed everything's going to go okay. So this is a very exciting time, but I hope you see how they got rid of the 25,000 miles per hour. It started with a parachute. It started with some very small engines, some very small fuel tanks to give a little bit of burn to slow the rocket down. It's about all they could do. But then that last bit to really stop the thing and give it a soft landing was those huge airbags. So that was their approach. Just wonderful. It's so exciting to watch that coordination, that engineering, that ultimately the success of the mission. So wow. Okay, so the next video will show you a different landing mechanism.